And finally, we're going to talk about some of the advanced settings for DNS in Windows 2012. So some of the things that we can configure forwarders, root hints, round robin, recursion, or how we configure recursion, and debug logging. And we'll talk about that as well under monitoring DNS, which I'll cover in this slide deck. So referring a DNS query to a forwarder can be more efficient than doing recursion under certain situations, like when a DNS server address for a target domain is already known. In other words, when a query comes in and you already know the IP address for the queries, you can just use a forwarder. When only one DNS server in a network is making external queries. So if any DNS requests come in for anything that's outside our network, it might make sense to forward those queries to a different server which will handle those requests. When you have a forest trust, such as with Active Directory, and when the target domain is external to the network and an external DNS server address is known. So you want to forward those requests outside of our network, for example. Conditional forwarding allows queries for a particular domain to a particular domain name server and all the other unresolved queries to a different server. So basically, using forwarders allows you to forward requests for DNS information to other DNS servers, as opposed to using recursion, which starts at the root and works its way down. So it's a little bit more efficient if you're able to do that. So if more than one server is specified for forwarders, so let's say you go into Windows and you create 4 or 5 forwarding servers, it'll always start with the first forwarding server, and then it'll work its way down that list, trying to get responses. And if none of that stuff works, then it'll eventually use a recursive anyway. So it'll fall back to recursive if needed. And this is where you set up your forwarders in DNS. So in here, this is where you're going to list the IP address for forwarders for DNS, for a DNS server. In other words, a request comes in, this tells it where to go to try to find information. Rather than trying to do a recursive lookup all the way out, to the root, it will use the forwarders instead. So you can configure conditional forwarders. A conditional forwarder is basically a forwarder that only works in certain circumstances. So it can be to resolve DNS queries in this order: from locally stored zone resource records, from the DNS cache, from conditional forwarders, and then traditional forwarders, and finally recursively by using root hints. So this is the order in which it does DNS lookups, a DNS server. So it starts from the locally stored zone resources, so everything that it has stored locally, then the DNS cache, then the conditional forwarders, and then traditional forwarders, and then finally recursive the old-fashioned way by using root hints. So so what is a root hint? A root hint consists of a list of name servers that are pre-configured in Windows DNS servers that point to internet root servers. So a root hint basically is, here are the root servers that we're going to query for DNS information. So these servers contain lists of name servers that are responsible for top-level domains. So the root hints data comes from cache.dns file that's located in your system32 directory in the DNS folder, just like some of the other files that we talked about. Internal DNS servers can be configured as root servers if the network is isolated from the public internet. In other words, if you're never going to be doing lookups or any DNS lookups out on the public internet, then you can have your own root server that's inside your network. But if that's not the case, if your expectation is that users are going to be able to look up things like google.com from inside your network, then you have to have a root hint that tells your DNS server where it can go for information about DNS lookups on the internet, so where it goes for wider information from the internet. Otherwise, DNS lookups will never work for anything on the internet if you make yourself a root server. Round robin is basically a way to do load balancing on the network using DNS. The basic idea is that you can create multiple A records. So let's say I have one DNS name. We'll call it ftp.mynetwork.com. And let's say I had 5 FTP servers that I wanted to allow people to connect to. You can list all 5 FTP servers as A records in your server. And every time somebody does a DNS query, it's going to change the order that those DNS records, those A records, are returned. Typically, the way this works is if you do a DNS query, you're going to try to connect to the first IP address that you get in the A record if you have multiple records. And if the first one doesn't work, then you try the second one, the third one, the fourth one, and so forth. So we could do round robin, we could do a little bit of load balancing with DNS by providing all of those IP addresses, but changing the order with each query. So with each query, we change the order a little bit so that we're always favoring the next one in the list. And overall, if you had 100,000 queries and you had 5 different servers, then each one should be at the top of the list 20,000 times, essentially is how that works. So it's a very basic way of doing round-robin load balancing by using DNS. And of course, some devices will cache those. So one of the problems with this method of doing load balancing is it gets cached, and you have to rely on those secondary A records to be utilized by the clients, which isn't always the case, unfortunately. But this is definitely a good option, and it's something that you can do. So again, you just list multiple A records, and it should round-robin those records. If you want to see how this works, you can do a DNS lookup for google.com, and you'll find that you get a whole bunch of different IP addresses for the A records. And if you try that query from a different computer, chances are you're going to get a different list or a list in a different order. And that's some of that load balancing that you're seeing when that happens. A recursive query is when we go out to DNS on the wider internet. So recursion is enabled on Windows DNS servers by default, but there are 2 ways you can change that setting. The first one involves configuring forwarders, and the second is to disable recursion. Also disables the forwarders in the Advanced tab under DNS. It's a good idea generally to disable recursion when you have a public DNS server containing resource records for your publicly available servers. In other words, if you already have a DNS records that has the public information, then you can disable recursion, or generally it's a better idea to do that. So like everything else, eventually we're going to have to debug and troubleshoot. So when DNS is installed, you'll have a new event log that's created to record information about DNS, and that'll be in the event viewer in Windows. So common events that you'll see in there will be zone serial number changes, zone transfer requests, DNS server start and shutdown, and debug logging can be enabled in the server property dialog box, which will record selected packets coming from and going to the DNS server in a text file. So that'll allow you to do some more advanced troubleshooting. There are also some, just like everything else, there's a few command shells or commandlets for PowerShell that you can use to manage DNS troubleshooting and to enable troubleshooting and logging. So to troubleshoot a DNS problem, you need to know that the DNS is actually being used for name resolution, and after determining that DNS is part of the process, you can begin monitoring DNS. In other words, people can add records to their local host file, in which case the lookup never happens, right? It never gets to DNS. So you want to make sure that it could also be a caching problem on the client side. So certainly another thing you could check is to make sure that the client has not cached records for DNS, that it's using a cached version. So first you want to isolate that the problem is actually with the DNS server that's actually doing a lookup. So if the problem is performance related, certainly will reveal itself if you're monitoring DNS. You can troubleshoot DNS queries and zone activities when there are query failures, which you'll see in the logs. Windows has several tools to administer, monitor, troubleshoot DNS server operations. So some of those tools are the DNS Manager, which we talked about. You've got some of these commands that you can use. Domain Controller Diagnostics, Test DNS, which will test your DNS server and output a log. DNS Command. The PowerShell has some tools. The Event Viewer, of course, which we talked about. And then we've got a couple other tools, NSLookup, for example, IPConfig, which can show you if you're looking at the right DNS server, and Performance Monitor, which will help you diagnose any performance-related issues, and Protocol Analyzer, which will let you look at the actual TCP/IP packets to try to identify, or in this case UDP, to try to identify exactly what the problem is if you need to get to that low-level troubleshooting. So in order to troubleshoot DNS queries, you have to have a clear understanding of the DNS lookup process. So these are the steps for DNS lookup. First, when you go to, let's say you type in google.com. The first thing that will happen is your DNS client will check its host file on the local machine to check to see if it knows the IP address from the host file, and then it will check its local cache, its local DNS cache. If it can't find the DNS cache, it's going to query the DNS server with a recursive lookup. So it'll go out to the DNS server and try to do a lookup. That server will then check the local zone data to see if it can find it. Then it checks locally cached data, and then it will query a root server or any configured forwarder. So it'll try all the forwarders first, and if none of those work, then it will try the root server with a recursive lookup. And recursive meaning it starts at root and it recurses its way through that hierarchical tree structure until it finds an answer to your question. So those are the basic steps. To verify DNS configuration, you can use the IPConfig command. You could use /all, which is going to show all of the information about how you're getting to DNS. So it'll show the DNS server that's configured for the machine from which you're doing that query. In other words, where are you going for the initial DNS lookup? Display DNS displays the local DNS cache. So that's how you can see what's in your local cache. When I said earlier you want to identify or isolate exactly where the DNS response is coming from. You could check the local cache to make sure you don't have something poisoning your cache that's causing those DNS lookups to fail. And then you can flush that cache if you need to. So if you do flush DNS, that will flush the local cache so that it gets rid of all of the stuff in your cache so you can make sure that it starts building that database again from scratch in case you suspect that something's poisoning that local cache. So after all of those steps, then you might also want to check the host file to make sure that you didn't miss something when you display the local cache. So the host file is going to have any static records or static lookups for IP address to host names that someone might add. Some malware used to do that as well, where it would automatically enter things into that cache. All right, so if everything checks out on the client, then you need to analyze the DNS server that the client is using. So that would involve looking at the locally cached data, DNS server logs, verify the Active Directory replication is working correctly, verify SRV records or server records. So we didn't really talk about SRV records in this section, but basically it's a part of Active Directory utilizes SRV records in order to look up different services on the network. For example, if you wanted to find a domain controller, you would query DNS server and say, tell me which servers have registered themselves as domain controllers. And it will come back and give you all of the records that are domain controllers. And there are other services that you can look up with DNS. And again, we didn't talk about that much until this point, but that's just another type of record, just like an A record or an MX record and so forth. You want to verify zone transfers are configured correctly, verify zone delegations. You can use the ping command to make sure you can get to the forward lookup zones, that you can get to the root DNS servers, anywhere that it might be doing lookups. And you want to verify your PTR records or the pointer records, which are the reverse lookup zones. So in summary, we talked about DNS being a hierarchical naming structure and distributed database, very similar to Active Directory. We discussed that DNS can be described as an inverted tree, right? So we talked about that inverted tree in that root DNS server. The DNS database is composed of zones and resource records, such as start of authority, host records, and SRV or service records. We talked about how lookups involve an iterative and recursive queries. In other words, it keeps trying to check until it can find an answer to that query through the tree structure. DNS servers can perform one or more of the following roles. They can be an authoritative server, a forwarder, conditional forwarder, and caching-only server. A zone can be a forward lookup zone or a reverse lookup zone. And DNS database consists of the following types: the primary, secondary, and stub zones. We talked about how a secondary zone is only used if it's a standalone DNS server, but when it's integrated with Active Directory, you can use primary or stub zones. When using Active Directory, it has automatic replication, multi-master replication, which again is part of Active Directory. It has the secure updates, and it's a little bit more efficient than using standalone DNS. Resource records can be dynamically created, or we can use static records that we create ourselves in DNS. So we can create DNS records ourselves, or we can rely on systems to dynamically create themselves, and DHCP can do that for us as well. We talked about the importance of an SOA record, which contains information about a zone, including the serial number and the number of times timers used for zone transfers, so how often the zone is updated, for example. We talked about some advanced DNS servers, like configuring forwarders, using root hints so it knows where to go for recursive lookups on the internet, using round robin in DNS for some load balancing, recursive queries and how they work, and we also talked about how to turn on logging, and of course how to monitor and troubleshoot our DNS server. And that concludes our discussion about DNS.